surrounding the apparatus, the device. So instead of a thing which is, you know, in the way of the wind, and the wind wants to around it, you can make some device which sucks it in. Yes?
Yes.
Okay, well, I'll get more sucking.
Not the
Sucking. Sorry. I am tired as well. I must look at the time.
You're half an hour on your way.
Half an hour anyway?
Yeah.
Okay. Oh, that's great. So, in a video, I'll give one more example of the vortex thing where it can be efficiently used, and then we move on. So this is about the workings of a fish. So how does a fish work? And I used to think that a fish was basically the same as a rowing boat, you know. And a rowing boat, you do, and you kind of you push against the water to make you go in the other direction. I thought a fish would kind of do the same thing, you know, with the tail like flop, 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 like a propeller, and it would push itself through the water. But that's not correct. A fish is the working of a fish is much smarter. So I'll try to make a drawing of it. So let's say this is a diagram, of course. I'm not a skilled artist. So let's say this is a fish, and water is coming from this direction. So fish wants to go.
This is a top view.
This is a top view.
Make the eyes.
It goes. Yeah, it's a top view.
Yes, is this a diagram or is that a real thing?
No, this is an actual fish. People saving the world is a serious business. Now concentrate.
No more entertainment.
Okay. Now I'll just represent the fish by a line. So this is a fish.
Which one is the fish?
Yeah. So what a fish does is it curls its body like this, so the water is flowing here. And by doing that, over here, that creates a whirlpool. So just by the flow of the water, there's a whirlpool here. Then it bends its body in the other direction, and you have a whirlpool here, which pushes the fish that way. And then over here, another whirlpool appears. Yeah, so only by changing the shape of its body, it is pushed by the water, even if it's flowing in the other direction. So, wow! Wow! I mean, how beautiful! How beautiful is that? And I know this from an internet video in which they developed technology which works like this, and they are able to extract energy from water that is flowing really slow, because apparently the majority of the flowing water on our planet is flowing relatively slow, and you cannot really tap energy from it, and also not create a whirlpool because there's not enough difference in height. But using this, the working of a fish, they are able to extract energy from it anyway.
Wow.
Yeah. Okay. Now let's move on then to the thing. If you recall, it was I called building down. This is also so. This is actually what I'm going to talk about now. Is the work of Buggy. This is his
this wasn't vortex. It's just the side.
No, not in the note. He didn't do vortexes. Although he did so many things, I would not be surprised if he did. But this thing is he did. Sorry if it wasn't clear. So that's why I brought these thingies. Just I'll throw them around, and then you can hold them in your hands, right? Have you have a question?
No, I want one.
Oh, you want one? Yeah. And pass them around, okay? There's one over there. So when you're holding it, then please notice that the wooden sticks are not touching. No. You see that? So with all of these models, they're a build-up of little elastics.
Rubber bands.
Rubber bands, yeah. Rubber bands and sticks, but the sticks don't actually touch. Yeah, will you... Oh, sorry, I didn't mean...
You have to hide up now.
Yeah. So they're actually, the sticks are suspended in a net. And the way these things work, there's two forces. The sticks are like pushing outside, that they push, and the rubber bands like pulling in, they pull. And by combining these forces in a nifty way, you get these things. Now these are toys that I actually created myself, or I didn't invent them. And they're made of rubber bands, but you can also make them with rope or cables or whatever. And it will also work with large beams. And well, you can look at it as a toy, but this also is, as it were, a way to enclose space. It is a way to create an inside and an outside. And as it happens, this is the most efficient way in terms of material and of, let's say in ways of material, to enclose a space, to create an inside and an outside. Now, to enclose a space is like, this is what building a house is, right? So when we build a house, we are working to create something inside and something outside. Now, let me briefly try to describe our mindset of crafting a house. So when you first start to build a house, you have to make the foundation, because what you're going to do is like really heavy. So the earth will not support it. First you start digging.
Dutch earth. Dutch earth.
Dutch earth. Yeah, Dutch earth will not support it. Yeah, specific. So first you build a foundation, and when you pour in a lot of concrete, and then when you level with the ground, you start building. And the building process is like you conquer every centimeter, every inch. You're conquering from gravity. And the higher you get, the more difficult it becomes. Yeah? So our way of approaching this and closing the space is like building up. You build from the ground, and you have to work, to battle, to gain your height. Can I have one? No, let's say this one. Now, the mathematics behind this is very complicated. I cannot do it, and even very, very smart people, I'm not even sure if we